first part will be done. Not the notes. Notes will be done by hand. Anything else will be done there. Go to attendance first. This is too much. It'll get too frustrating to do the notes on Candy. Yeah, I put the slides there because those that are working at home will have to deal with the Candy.
Exactly the way. Figure out a way how to do it without typing it on.
All right. 3 ways groundwater can get polluted.
By us humans pooping in the body.
Even the bathroom in the water is
Pest. Like,
pesticide.
yes.
And you can't poop in your groundwater.
Right there. Tell me, you say pesticides, Alicia? Yes,
Instead of
pesticides.
pest, but
Oh, pets.
I couldn't think how to say it. That is my pencil. Yeah. Yeah.
Pesticides.
Okay.
Oh, something else that was listed there.
Fertilizer.
Where do the attendance? You should be in. Be typing. Oh, I didn't even spell that right.
FER. Fluid systems.
Ah, yes, sewage systems.
Exactly. Pooping in the water.
Well,
Oh, now I get it.
Do you there?
typed in, it's fine if you put 4, and submit it.
I have grades now. Not had. Big deal.
Nope. All right. We're going to be talking about rivers today, so we've got quite a bit of notes to get through. So you can move the- We're going to look at river health today, and hopefully we get the second part, which is just river basics. So I want to kind of move completed and submitted, and then you can close up your computer for right now, those of you that are here. We're going to be looking at indicators or river health, which will be indicators of water or river health. So what makes rivers healthy? I guess I'm not presenting. Um, no, I'm recording. I just didn't get the presenting going. So let me go back here. Thought I was presenting. I may have not done a video right in my other class. I thought it was presenting. All right, so let's see if we can see now. Yep. All right, so on you guys have yellow paper because that's somebody put that in the copier when I printed it. So we're going to so if you notice, the first term there on the left-hand side is turbidity. Turbidity is just the measure of the degree to which water loses its transparency due to the presence of suspended sediments. In other words, the cloudiness of the river. If it's not clear, then it's turbid or it has a high turbidity. So here's a picture of the Mississippi River with high turbidity. So it looks right now very muddy. You can't really, it's not clear water. So when it's not clear, that is what we call turbidity. So in that blank, the measure of the degree to which water, and you're going to put loses on your paper. We're not using the computer camera. Well, then you need to set that to the side for right now. Right now we're doing this. That should have already been typed in. So you're writing in that blank, water loses transparency. Water loses transparency. Water loses its transparency. So just be familiar with that term. So if a river has a high turbidity, it's not going to be very healthy. All right, here's some examples of turbidity. Notice that the darker it is, it's because the higher the number is, which is the turbidity, that means it's got more stuff in the water and it's not clear. So you want the river to be clear for it to be healthy. So that's just showing you examples of various stages. So 10 is mostly clear, so it'd be a healthier river. Right. The lower the number, then the clearer it would be. All right, so some causes of turbidity, which are not on your sheet right there. You can get it from sediments, so erosion. Maybe sediments from the bottom of the river have been stirred up. Waste discharge, so waste that's getting into the river. Algae growth, or urban runoff. So those are some causes. There's not really a spot for you to put that. Next is pH. So when scientists are taking a look at their or testing water quality, one thing is pH. You do not want a high pH for a river. You want it to be close to 7. So notice that if it's 0 on the pH scale, this is what we use to measure how acid or basic something is. 0 up to 7, so 6.9 is acidic. So 7.1 and above is basic to 14. So surface water, this is the range that they want it in, 6.5 to 8. So 6.5 to 8. Swamps, if they were to test it, would be very acidic. And I just realized something. There's a second column on your notes, and we're going to back up in a minute for you to put the causes, and we'll get those causes in just a minute on the other slide. I forgot that column was there.
Turbidity, pH,
yeah, I just realized it because I wasn't looking at it. So we'll go back up in just a minute. So when pH changes in a stream, it's an indicator that there's pollution. And so you're going to start seeing some things. So we're going to back up a slide a minute. And if you will look to the left of turbidity, that's where the causes were. So we're going to get before we get the causes of pH. So in the first blank, you're going to put sediments from erosion. And then the fourth blank, you're going to put algae growth. So second blank, you're going to put algae growth. blank, sediments from erosion. Or you can just put sediments if you know it comes from erosion. And then algae growth for the second. All right, the causes of pH right under there. Natural conditions can cause it. What? You're good?
Yeah.
All right. So that's given. Then the next one is dumping. And in that blank, you're going to put waste. Next is farm runoff in that blank. And any of these will cause changes in pH. And the issue is aquatic life cannot withstand a change in pH. They have to have their environment at a specific pH. And so when the pH changes, just like in this picture, you're going to start seeing lots of dead fish mainly and any other organisms that live in the river.
That's a lot of dead fish.
And so
Or they'll mutate.
this picture here is probably an exaggeration, but it could have been a real incident. All right, so next, dissolved oxygen. Water has dissolved oxygen in it, and so you need the definition. And so it is just the amount of oxygen in water. So the amount of oxygen in water. And when this gets too low, fish is going to die. And if it's too high, the water will taste better, but it damages water pipes.
Water tastes better.
It's a lot of times they'll use oxygen stuff to purify it, so it gets out some of the other chemicals. It helps get out the chemicals, so it will taste. Oh no, not the fish, the water. All right, so look over in that other column under changes caused by where it says rapidly moving water. So if water's moving rapidly, it can increase the amount of oxygen. If temperature is increased, it will decrease the amount of dissolved oxygen. And discharge from sewer pipes decreases the oxygen, and because sewer pipes have sewage in it, it also causes an increase in bacteria. Oops, did everybody have that? I clicked and I didn't remember. So dissolved oxygen, still talking about this a little bit, is I've already said this, if it's too low, fish is going to die. So dissolved oxygen kind of varies in the streams. So during the day, you've got respiration that's occurring and decomposition, and those are going to consume some oxygen. Photosynthesis is producing oxygen in plants and animals that live in the water. At night, you don't have photosynthesis, so you don't have any oxygen production, but you still have respiration and decomposition that contains oxygen consumption. So it's still using oxygen. So in the day, it's kind of balanced. At night, it's going to drop a little bit. But that's sort of a natural cycle unless there's other things taking place in there. The next one is temperature. Temperature, you need the definition. The basic definition is it measures how hot or cold something is. And we can have extreme low or extreme high temperatures. And these are only tolerated by what we call hardy fish. There are certain fish that can withstand major temperature changes and still survive. Most cannot. And so if you look over the column for changes in temperature, In the first blank, you're going to put source of water. Where is the water coming from? Is it coming from a heated spring or a hot spring? Is it coming from high up in the mountains? It would be cooler. The depth of the water, shade of the shoreline. And this last one is bolded for you in the temperature column. It's already written. What changes the temperature that's man-made is pollution. Factories, pollution. If they dump heated water into lakes and rivers, it's a quick increase in temperature and into that body of water, and it causes species to die. So that was already there for you. And then nitrates. Next, definition, fertilizer, ingredient is all that you don't have to put the rest used in agriculture. We know that fertilizers is used in agriculture, but you could put fertilizer ingredient. What this does is it allows when more nitrates get into a water source, it is food for algae and other plants because they use it. And so they will start rapidly growing. And this causes a problem called algae bloom. And so if you see a pond like this that has a lot of algae growing, it means there's been an increase in the nitrates more than likely. And what this does is this algae then uses the oxygen, causing the dissolved oxygen to decrease, and eventually aquatic insects and fish will die. So blank wise, this algae bloom right here reduces in that blank under the bolded section in definition. Everybody got that? All right, all right. And I down here, improper use of fertilizer is in the blank to the right. And so, which river here has excess nitrates? Well, it appears this one right here. Look at that. I don't know if I'd swim in that one. Right here. With all that algae there. I don't think I would swim there. So this one would there probably be a source of excess nitrates here. All right, bioindicators. Bio, remember, is life. And so indicators. So the definition is already there for you. These are certain species that are used to monitor the health of an environment or ecosystem. So, and how they do this is they are monitoring the population and individual health of the organism. An example is usually one of the main ones is amphibians. So, if you have a decrease in the number of amphibians, like frogs, then in the population, then more than likely there's an issue with that water source. So, there's really nothing to fill in there. If you'll flip your paper over, see if I've got to, I may have to open the next one. All right, so here's an example. Producers, primary consumers, secondary consumers, tertiary consumers. So if you have a decrease in any of the bottom two, it's going to have a trickle effect on up. So you've got to have a large number of producers and primary consumers to support these secondary and tertiary consumers. So it kind of feeds up, it affects the food chain, in other words. So let me do this, and we're going to look at the second slide. So if you flipped your paper over, at the top it says river basics, streams, erosion, and deposition. So we're going to go over the major parts of each of the rivers. So rivers and streams. We don't have anything to write down yet. This is just where the water table meets the Earth's surface. So we're going to go here. Headwaters is where we're starting. Definition, beginning of the river. Headwaters, beginning of the river. Usually in the mountains. So in the mountains, you have all of this runoff that flows into the valleys, and these valleys become saturated, and everything will flow to its lowest point and collect, and as it keeps going downhill, it's going to flow. Mountains. Usually found in the mountains right here. All right. Definition, beginning of the river, the blank, mountains. All right, tributaries. Definition, these are smaller rivers that feed into a bigger river. So the Amazon River is not the longest river, but it's the river that contains the most water because it has all of these tributaries, smaller rivers that flow out from it. And so the first bullet, the Amazon River is in South America, and it starts in the mountains of Peru over here, and it flows to the east to the Atlantic Ocean and empties into the Atlantic Ocean. And it has all these tributaries that branch off from it. So typically, rivers are going to be starting in the mountains and going toward the coast. And if you notice, you have more tributaries in the mountain area than you do as it gets flatter toward the coast. All right, the mouth of the river, this is sort of the end of the river. It is where it flows into a larger body of water. The mouth of the river could be a lake, it could be an ocean, or even another river. So it's where a river flows into another flows into a larger body of water. For most of our rivers in North Carolina, they flow into the Atlantic Ocean.
And some lakes.
All right. Okay, come on, Cameron, get it written. I'm waiting on you. You can shorten and say river flows into body of water. Into large body of water. All right, watershed and river basin or drainage basin. You'll hear all of these terms and they kind of mean the same thing. So it's a region of land that contributes to water, to a stream or river. So that's the definition. And if you'll look here at the map, Stanley County is located somewhere in here. We are in the Yadkin PD River Basin or watershed. We're in the Yadkin Valley PD. That means those are the two main rivers that flow through our area, and all of the water in this area drains into those rivers. And so that is our river basin right here. So you may want to circle that on the map, the Yadkin PD, in case you're asked. Yadkin PD is between Catawba and Cape Fear.
At Cape Fear, we just.
No, Yadkin PD. Yes, it goes all the way because the PD River actually goes through South Carolina before it empties into the Atlantic. The Cape Fear and the Neuse, two big rivers in North Carolina, and there are other ones here. But the Yadkin PD River. All right, divide. If you have been out west, I think somewhere in Colorado, you can drive across what is called the Continental Divide. And so what this does is it's a boundary that separates streams of adjacent watersheds. In other words, on the east of the Continental Divide, all rivers will flow to the east. And west of the Continental Divide, they flow to the west. So that's what it means there. So it kind of divides the watershed so that you have those that are flowing to the east, those that are flowing to the west. So
That D word on
drainage. All right, so this should be written so we can move on. Just boundaries that separate streams of adjacent watersheds. All right, on the next page, channel. The channel is just the course of the river. So it's the path the river takes. So channel, you'll hear course of the river. It could be the path of the river. It is path that the river stream is following. It is we tend to call it the course of the river. But course is the same thing as path. So you can see this one going through the plains here. It's very windy. We have a term for windy. It's called meandering. So I remember teaching this one time at middle school level, and we had to line up and go somewhere. And so I always had meanders in my line because my line was never straight. And if these two meet right here, it forms what's called an oxbow lake. If they were to meet, I don't know if we'll get to those terms or not. All right, gradient. A gradient is just a slope. All right, so you could just put slope. And so it's the slope or steepness of the channel. And so typically it's expressed as a vertical drop of a stream over a certain distance. So they'll measure the slope for a distance, sort of the elevation. So it's the change of elevation. So you have a steep gradient at the head, and then as you get closer to the mouth, it's a more gentle gradient. So that's what it means. In the mountains, you're at a higher elevation. So gradient is the slope of the channel, the river channel. Slope of the river channel. Okay, discharge of the stream. This is the volume of water that flows past a certain point. So if that scientists had a equipment set here to measure the velocity of the river, they would be seeing how much of that water is flowing past that point in a given amount of time, and they would calculate or find the velocity of it, and it's cubic meters per second. So volume per second. And so that is the discharge. So how much water is passing a point in a given unit of time. Get that under discharge. All right, so here are the top 10 river discharges. Look at the Amazon. Look how much water it discharges. So it is discharging the most. The Nile, which is the longest river, notice it's not even up here in the top 10, even though it's the longest. Its discharge, it doesn't even rank in the top 10. Um, so it has to do with the elevation probably that it starts and how many tributaries that come off of it. The Amazon has a huge number of tributaries. The Congo River, which is in Africa, has is second. I can't pronounce this, but I think this is in China. I'm not sure where some of these others are. Those are the ones in Mississippi, of course, I know where is, but the others, that one's probably Africa. Some of these other ones, I'm not sure exactly where they are located, but the Amazon discharges the most. All right, so steam load or stream load. Stream load. First bullet is the definition. So you're going to start the solid matter carried by a stream. That's what you're going to write there. The solid matter carried by a stream. So as a stream flows or a river flows, it picks up sediment. It picks up rocks. It picks up particles. It picks up pollutants. Any solid thing. It even picks up trash that people toss in. So solid matter carried by the stream. Erosion, this movement is going to erode, and so there's going to be mineral material. It's going to erode the rocks. You're going to get minerals into the stream, adding to this material to the regular flow of the water. So you're going to have, there are chemicals in water. Even if you have a well, your well water has some chemicals in it, natural chemicals from the eroding of the rocks that's around it. So the solid matter carried by a stream. So the higher stream velocity means that you have higher stream load. So the faster the river is flowing, the more solid particles it will carry because it can erode more. All right, sediment. These are those solid particles. In that blank, you're going to put decrease. So sediment is deposited when there's a decrease in speed. So if it's flowing, when it reaches a point, it slows down. That's where you're going to have it deposit the solid particles that are in it. We call this sediment. So the speed can decrease for these reasons. Number one, you need to write down change in gradient. Number one, write down change in gradient. Bed widening, that means the channel gets wider, so the path becomes wider. And then three, obstructions. If there's obstructions in the river, it can slow the river down. So stream deposition, that just means the deposits of sediments from the stream, can create some landforms and change a river valley. That's what we're going to look at next, is some of these things that can be formed or changed. The obstructions is the third. All right, alluvial fan. Alluvial fan is just a sloping fan of deposits. So right here, see how this looks like if you were holding it here, it would spread out like a fan. So this river has deposited in this manner these sediments. And so this will occur when a stream that's going downhill reaches flat land. So an alluvial fan. So it is a sloping shape, so you need to write the definition, a sloping fan-shaped deposit of sediments. And this is happening when streams that are going down a slope reach a flat area. Levees. You probably hear about these more of the artificial levees, but they are natural levees. This is riverbanks that are raised and caused by flooding. We create artificial ones, so we build an embankment to prevent the overflow of a river. So it can occur naturally, or we can form them. So natural levees, so if this was before a flood, here's the river, it floods, well, the water is going to slow down and it's going to eventually drain back here. It's going to leave behind some sediments. And over time, it builds up a mound of new sediments here, which is a natural levee. So eventually it'll be harder for it to flood there. Especially in, I think Louisiana has quite a few artificial levees there in the Gulf, but it's where we build up on purpose the land to prevent a river to overflow. floodplain. This is the part of the valley floor that gets covered with water during a flood. If you live in an area like that, you're going to have flood insurance because it is probably going to be expensive because when the area floods, you're going to have damage to your property. And so a floodplain forms where a stream cuts mainly side to side. And so you get sediment deposited and it makes floodplains very fertile. If you remember from world history, the Nile Valley floodplain or delta area is very, very fertile and then there are times when it is not. Um,
I'm just gonna be this.
all right. Do you have this, Camden?
I'm already on the meeting.
Okay, well, hold on. So precautions, we have artificial levees that we can build to prevent flooding. You've got flood insurance that you have to have. If you live in an area, you've got to be prepared to evacuate. You want to, governments need to limit the development of floodplains, building in those. So why limit it? Because this allows, if you're building on it, it can't absorb water. So if you're not building on it, then it's going to allow the water to absorb and it prevents structures from being put in harm's way. So it's just a precaution there. So now we're on the last little part here. Meanders I already talked about. This is where the river curves, and usually it's because of an obstruction that happens, and it curves to go around that obstruction, and it creates these meanders or curves. And so erosion will occur on the outside of the bend, out here, and deposition, it will deposit sediment here. So this area will build up, this area will be broken down. Oxbow Lake is where the meander has occurred, but as it keeps going, eventually the two sides of the meander will meet and it'll deposit sediments and close off, and you'll have what is called an oxbow lake. And so it's a crescent shaped body of water that is a result of a meander when a meander is cut off. And so this is usually naturally occurring. Do you have that?
Yep.
Here's just an overview, an aerial of some rivers, so you can see sort of the different meanders and possible oxbow lakes and things like that. All right, stages of development of rivers. So you've got them in three little columns there. First, you have a young river. It has usually a V-shaped channel. Its sides are very steep. So as it matures, its channel is going to be more U-shaped with more sloping sides and some meanders. And an old river is going to be a flatter U-shaped channel with sloping sides, lots of meanders, and oxbow lakes. This has been there a long time. You good? No? Okay. And the features would be like some meanders for mature and lots of meanders and oxbow lakes for the old. We have two more left. Yeah. All right, so here gives you a picture of a V-shaped valley. So that's be a young river. And then when it widens out, it's going to be older, the flatter the valley gets. So here would be kind of a midlife. You've got some meandering. Here you've got very sharp meandering, some oxbow lake here. This one's getting ready to be one. So this is an older river. Delta. This is a depositional feature built up by sediment that forms where a stream enters a lake or ocean. So it's going to be at the mouth of the river. And this is a picture of the Nile Delta. This is can become very fertile due to its flooding. Uh, the Delta region is where the Egyptians would do a lot of their growing and crop production, and they wanted the river to overflow because it then would, um, when it receded, it would leave fertile land. All right, you good?
Yeah.
All right, then here's some pictures of some of the Mississippi River Delta. So you kind of got several different areas here. And this is all here around Louisiana. And the Delta area, especially if they start building on it, is going to have a lot of flooding issues. All right, so building a dam. A dam is just a barrier that obstructs the flow of water. Usually they're built for hydroelectric power. Also, it creates a storage place for water. Lake Tillery was created. It's a man-made lake, and it was created as a storage place for water. And when they release the water, lower the level of the lake, it helps produce hydroelectric power. This creates recreational facilities. It can cause or have irrigation, can allow for irrigation. But there are some disadvantages. One, you increase the accumulation of sediment in the water. It's going to become more turbid. They're expensive to build, and it actually destroys natural habitats for plants and animals. Some fish have to get downstream to either lay their eggs or either to mate. And when you build a dam, it kind of prevents that from happening. So that's what they're doing there. And so here's a picture of a dam. Um, all right, so on the last page, and I may have to pull this up, you're going to be labeling this. So let me go in and pull it up. Give me just a minute here.
Are you talking or are you saying?
Yes. Try to be quick though. Let me get to where it is. And Maya, since you're still on here, I'm gonna keep going even though he's not here once I get it up so that you can get, oh, I typed the wrong year, that's last year.
All right.
You can get it as we, well, if I can ever get there. Science. And just for those that are remote, you'll be email your progress reports, or somebody will email your progress reports to you. It'll be your third block teacher. Um, and if you are failing a class, you will eventually be assigned some credit recovery units to try to make up for the units that you have not done well or that you haven't done. And then also you'll have an exam schedule. If you have an EOC, you will have to come to school on that date to take that EOC. Otherwise, um, your exam will be some sort of project or written exam that you will do on the computer. Uh, stuff. I went through all that, and I needed to go this way. Oh, Miss Noel. All right, get Google Drive. get right on it if I don't go through Tammy. So of course, I realize that after I get to it. So remote students, be on the lookout from an email, either from Ms. Swearingen or your third block teacher that will have all your progress reports in those two letters. And then at some point, you'll get an email from Dr. Russell, who's our assistant principal, with the information on how to get into your unit recoveries. All right, so now that I finally get it up, we're going to go through and fill this in. So let me move some stuff here. Let me get down to the bottom. All right, so right here, we're going to do this together. So Camden, easy points for you here. And Maya, who's online. So we need to label the words here. So look at our words here. We've got head of river, stream, wetlands, watershed boundary, stream meanders. So, oh, tributaries, yeah. All right, so let's look at number one. It's pointing to the mountains. What did we say? The mountains. Which one of these? Is it the start or the end of the river? What do we call the start of the river? Head of the river. So we're going to write head of river here. We're going to mark that one off. All right. I'm going to go ahead and jump down here to number 10. What are we going to call the ending of the river? No. If this is the head, what's the ending? What's underneath head up here? Mouth of the river. All right, now let's look at number 4. Yes, main river. I'm kind of going to jump around. Number 8 should be easy. It's the curves. Meanders. Yeah. Let's see. I'm thinking number 9 is going to be wetlands. And I would think 3, no, 3 oh, hold on. No, no. I think 6 may be our floodplain. 7 is pointing to this outer boundary here, and you'll actually see in one of the videos on Friday that this is what we call our watershed boundary. Yeah, for 7. And floodplain. Look at 5. It's pointing to 2 different things. Tributaries. Now, number 2 is up here. Number 3 is down here. So, 2 is here. 3 is here. So we've got upstream and downstream. Yep, upstream. And 3 is downstream. Okay. Then Yep, and then we come here. So we have three rivers. We have A, B, and C. Which one has the highest gradient? In other words, on the side, it has the highest slopes. A, B, or C? A has the most whitewater rapids and falls.
Cameron Riddle?
He already learned. Yeah. So I would assume it would be B, maybe A, but I think it would be B because you got to have all those twists and turns. The lowest gradient, C, the youngest at its earliest stage would be uh, A. Remember, youngest is going to have the V-shaped valley, so on each side it's going to be real steep. The widest floodplain, look right up here, it says floodplain well developed. So it's going to be river C. Least likely to flood is going to be A because it's so high on the sides and has the most depositional features. Probably B. All right, so if you're remote, you will submit this when you've completed it in the assignment. If you're face to face, you'll turn it in to me. We didn't get to the other thing I had for today. So we'll have to work a little bit on it tomorrow as well. But I want to talk a little bit about how things kind of look. There's a little North Carolina activity that we start some wetland notes tomorrow. We'll be finished with the freshwater. Friday, you just have videos to watch. So for your Friday assignment, you have videos on these topics we've been discussing. Um, and a Kahoot because Monday we'll do a wetlands web quest and Tuesday we're testing. So we'll play Kahoot on Tuesday and test. Wednesday we're going to start oceans and after Thanksgiving I will have more information about what you'll be doing for your final exam. But I will only get through oceans. I won't get into plate tectonics or much of ecology. So that's just kind of how things have wound up. So, yes. Any questions, Maya?
No, I'm good.
Okay. If you will just mainly work on catching up under hydrology, this
Yeah.
unit here, you'll be signed the other units in Edmentum. And what it usually involves is whatever, how many ever topics it is, you'll have a tutorial and a test to take. And as
Mhm.
long as you make 60% in that, it can be replaced for your test grades for those
Yeah.
units. And hopefully it'll be enough to get it up to passing for you. So if you
All
can
right.
just work on here in hydrology, which started back on the 12th
Mhm.
with water, the video water cycle, go through and do that. And there are some things well, I don't think I have them here. But anyway, if you'll do that, and I'm a little behind posting videos, but you've been on the last few days, I'm going to try to get some of the other lesson videos back up that I'm kind of behind on. And then some days I didn't have anything.
All right.
But if you'll work on that, and then you'll be getting a message from Dr. Russell at some point
Mhm.
um, that will tell you